Hey guys, and welcome back to another Godot Python MMO tutorial. In this part, I'll be teaching you how to set up your game for deployment in production. So we'll be securing our game with secure WebSockets, and we'll also be hashing our passwords before we store them in a database so that we have encryption at rest. We'll also be going through how to set up your own dedicated server for free for the first 12 months using Amazon Web Services. You can connect to your server easily through the web, and you can run your own game on this server that anybody can access from worldwide. So I can show you, I can prove to you that I'm running this online. So we can see here we've got the game server running, and these are all the packets that are coming through. And I've also connected me and my friend on itch.io, and we're playing this through our browser, connecting completely online through the internet. All of these packets are secured and encrypted with TLS technology, so it's fine if someone intercepts your traffic, they won't be able to tell you what your password is. And all of these passwords are securely stored and encrypted using a Django authentication module. So we also have our own domain name completely registered for free using this service here. We have to log in every 6 months to make sure that our domain doesn't expire, but you can set yourself a calendar reminder for that. So I have mmotbat.largent.org, which is a free domain that I've registered, pointing to my Amazon server's IP address. And yeah, we can play the game together. So that's what we'll be going through in this tutorial, and hope you come along for the ride. And as always, if you want to follow along online, and I definitely recommend you do that for this tutorial, you can come on over to tbat.me, click on the posts, and then click on this latest blog post. So securing and deploying our Godot Python MMO. And you can see there's quite a few code snippets and screenshots here that I've tried to include all of the detail necessary, so you shouldn't get stuck. But if you do get stuck, also note that you can come on over to the Discord and you can ask questions. So yeah, this blog post this tutorial has a lot more code snippets that you'll just be copying and pasting, so definitely recommend following along in the blog. So I'm going to start by coming into the official Godot Python GitHub repository, and I'm just going to download the end of lesson 5, which was the end of our core lesson. So I'm just going to click on assets and download the source code. So we're going to start off by assuming that you don't have the code that you followed along with the end of lesson 5 anymore. So I'm just going to download this zip file that contains all of the code that we covered in the core lesson. And I'm just going to extract it. And I'll choose to extract it to just my documents folder. So now in my documents folder, I have this folder, and I'm just going to rename it to MMO. So if I open this folder up, I have a client and a server. And I also have a .gitignore file that we'll use later. So the best way to follow along with this particular tutorial is we're going to try to host our code on GitHub. So once we have a working game, we definitely want to put it somewhere accessible on the internet, especially so that once we have a server up and running, it's very easy to pull latest updates, latest changes on the server, and push them to the final product. Let's come to github.com. github.com and click sign up. We're going to enter our email address, choose a password, and then we'll choose a username. Click on create account, and then just check your emails. When you enter the code that you got from your email, you come to this page, and we just ask a few questions, but you can just click skip personalization. Now that we have our account set up, we want to click this create repository button on the left, and we'll give our repository a name. I'll just call mine MMO. Make sure it's set to public, and then just click create repository. So now we're just going to ignore all of these instructions because we already have our game files here. We just need to open up a terminal window inside this folder, and we're going to run a few commands. So I'm just opening up Windows PowerShell, but if you are using Mac, you'll use a terminal, and if you're using Linux, I'm sure you'll know which terminal you need to use. So we're just going to run a few commands. So we'll run this first command called git init. And if you don't have Git installed, you can Google how to install it, and just make sure you close your terminal and open it again to follow this step again. So we're going to type git init, and it should say initialized empty Git repository. Next, we'll run git add space dot, and that will add all of these files to our repository. And I just have a lot of line ending warnings because I'm using Windows, but you can ignore these if you get these warnings as well. So we're going to run git commit -m initial commit. So M stands for message, and then this is the message for our commit. So we'll run that. And if you've just installed Git for the first time on this machine, it will ask you to set your identity. So you can just run these commands that it tells you to run. So I've just run the global user email setup. I've used my email here, and then the user.name, I've just put my first name here. So we can press up twice to try that commit again. And you can see now that it's committed all of these files. So next we're going to create a main branch. So git branch -m main. And then we're going to run git remote add origin. And we're going to use the URL that we got from our repository when we created it in GitHub. So that will be this URL right here. So it's github.com/your username and then / the name of your repository. So I'll just copy that URL and paste it into this command, press enter. And then finally, you want to run git push and then type your username and then an @ symbol and then just the same URL for this repository that you typed before. So, but just without the HTTPS the second time. So it should say https:// your username @ and then github.com/your username again / your repository name. So press enter and it should ask you to sign in with GitHub. So just click sign in with your browser and it should just open up a window in your browser that you can click authorize Git credential manager. So then you can close this tab, go back to your PowerShell window or your terminal window, and you'll see if it worked correctly, enumerating objects, pressing, writing, and then to the name of your repository on the main branch. So if you actually refresh this GitHub page now, you'll see all of your code has been uploaded. So we have all of our code on GitHub. That's a great first step. So we can close our terminal window. And the next step is we're going to add to this code repository, we're going to add a couple new features that are required for some online security when we deploy our game. So the first thing we're going to add is called encryption at rest. So this means that currently, because our game is storing all of its passwords in plain text, we definitely don't want that to be in production, because if anyone ever gains access to our server, then they'll have access to everybody's passwords. So instead what people do is they use something called a hashing algorithm, and it's like a one-way function so you can put in a password and get out a hash, but there's no way to turn a hash back into a password. But it is still possible to know whether somebody knows their own password, because the user will input their username and password, and then our code will put it through the hash and see if it matches with the hash in the database. So every hash is unique. So we can still tell whether or not players are able to sign in, but we won't have any knowledge of their password. So that's the first security feature we're going to implement now. Come back to your MMO folder, and we're going to open Visual Studio Code inside this folder. So as always, just right-click on the server folder and click Open in Integrated Terminal. And here we don't have our virtual environment set up because we just downloaded this code from GitHub. So we'll have to set that up now. So as always, it's python -m venv and then /venv. Press enter. Okay, next we're going to activate the virtual environment. So in Mac and Linux, you write source ./venv/bin/activate. But in Windows, you can simply type ./venv scripts activate. So now we're going to install Autobahn Twisted. So if you're using Mac or if you have the ZSH terminal on Linux, the command is slightly different. You type pip install Autobahn, and then you need to use these backslashes to escape the square brackets, and then just write twisted inside that, and then / close square bracket. So that's if you're using ZSH on Mac or Linux. But for everyone else, you don't need to have those backslashes before the square brackets. So we'll install Autobahn Twisted. And then we'll install Django. So now that all of our prerequisites are installed, we need to run our initial database migration again. So in the server folder, just create a new folder called migrations. Right click and make a new file inside the migrations folder called init.py. And this will just be a blank file. And now we can run python manage.py make migrations. We should see some stuff come up in our migrations folder, and we also see our db.sqlite3 database file here. So now we just run manage.py migrate. Okay, so now if we run our server, and we can see that it's running on port 8081. So we can open up Godot. We can import a new project because we just downloaded all of this from scratch recently. So documents MMO client, click import and edit. We'll just check the main.gd script is connecting to 127.0.0.1 on port 8081, which is the same port that the server is running on. So we can click play and we should be able to register. Okay, so we got the game up and running locally. So we can see the server logs are logging things and the client is receiving packets and interpreting them correctly. So we can close the client and we can stop the server. So we're sort of at the place that we would be at the end of lesson 5. And we also have all of our code on GitHub. So the first thing we need to do is implement encryption at rest. So like we were talking about, we want to hash our passwords before they go into the database. So luckily Django can help us with that. All we need to do is open up manage.py, and inside this installed apps array, we're going to add 2 new apps. So keep the server app, but we're also going to add django.contrib.auth. So this will help us hashing our passwords. And we'll also import this just because I think it complains if you don't also import this one. So we can save manage.py. And we're just going to move on into our models file now. So models.py in the server folder, and scroll down to where we had our user class. So we don't want this anymore. We don't want to be making our own user class. So we'll just get rid of that. But you'll notice that like in protocol.py, we have a lot of references to models.user and things like that. So we definitely want to keep using something called models.user. So this is our own models module. And we had a user class, and we don't want to write all of this code again. So what we can actually do is we can come to our models.py, and at the top with our imports, we can import something from Django contrib auth, which is now an app that we have installed. And we're importing the models, we're importing their models from this auth library, and we're importing that as auth models just so that it doesn't conflict with this models. And then what we can do is then we can just say that our models.user class is actually the auth models.user class. So this is kind of like making an alias. So when we reference, for example, again in protocol.py, when we reference models.user, that's actually referencing this thing here. So we're using the new fancy auth models.user. And you can see users within the Django authentication system are represented by this model. So yeah, username and password are required just like before. There's some optional other fields as well, but we won't be using those. So we can save models.py. And now we just need to go to protocol.py and we need to make a couple small changes. So the first change is we're going to also import something from Django contrib auth, and it's a function called authenticate. This function will take in a username and password, and it will determine whether or not they are correct. So because we're dealing with hashes now, it's not as simple to check for authentication like we were doing before, but this function will help us do that. So now we're just going to change our login state. So all of this code here, we're going to replace, and then we just paste the code in from my blog, and I'm just going to paste over that login function. So fix the indentation. So I've changed a couple of things. So I can click on this source control tab, and I can show you what's changed. If I click on protocol.py, it'll bring up this kind of diff view. So you can see like the first thing that's changed in this file is we've added this new line at the top, which is fairly obvious. And then all of the other changes are in this login state. I've removed this old check to make sure that the username and password was correct. So we were just literally checking if the username was equal to the supplied username and the password was equal to the supplied password. But we can no longer do that because the supplied password is going to be plain text, but the database password will be hashed. So now we are using the authenticate function. So we're making a new variable called user equals authenticate, passing in the username and password in plain text. And you can see this function says, if the given credentials are valid, returns a user object. So we're potentially getting a user object here if the credentials were valid. So that's why in the next line we check if user. So basically if this is not null, then we'll go and do all of the same stuff as before. No problem. Okay, well that's fairly straightforward. But you can see we're also changing our register logic here. So I've taken out a bit of a chunk. So I've added a bit of a chunk of logic here. And that's just because using the new Django contrib auth user, it doesn't allow for an empty username and password. And we shouldn't have allowed that either, but that was something that was possible before. But now we're just adding a check to make sure that username must not be empty and password must not be empty. And if one of them is, then we'll just send a deny packet that says username and password must not be empty, and we'll just return from this function. So we don't want to continue any further if we get this case. And I kind of just fixed up a little bit of the indentation. I thought there was too many layers of indentation here. Like, so because we're already like returning early in this case, I thought in this case, the same as before this case actually, but I thought we'd do an early return and then just this code doesn't have to be indented in an else block. So just kind of made this part a little bit cleaner, but this is the check to make sure that the username isn't already taken. And if it is, then we'll just return. Oh, and then this code is different as well. So previously we had, we were using our own custom user class. So we were just supplying a username and a password. But this time we're using the Django contrib auth user class, and there's a function called create_user, and that will do the hashing for you. So you just supply the plain text username and password, and it will create a user model object, which you can save to the database, and the password will be secure. And then everything is just the same as before. So these are just a couple small changes we made to protocol.py. We need to do a database migration, and because we've changed our database structure quite a bit, probably the best way to do it at this point is to just delete the db.sqlite3 file, and then just delete anything in the migrations folder except for the init.py. So I'll delete this, and you don't need to delete the PyCache folder, but I'll just delete it anyway. So the only thing in this migrations folder is init.py. So now we can just run our migrations again. So make migrations and then migrate. It added a few things now from this auth app. So yeah, there's a lot of features that we're not going to use, but the main important thing, passwords are secure. And we don't actually need to change anything on the client side. That will still all work correctly. So if I run the server and I try to run the game again, I can register for an account. So I'll make my username Tristan, and I'll just make my password 123. If I click register, it tells me the registration was successful. But now look at this. Let me close the game and I'll Control-C out of the server. So on Windows, I have this installed, but you don't need this. I'm just going to show you, prove to you that that my password is not stored in plain text. So SQLite 3, and then I'll pass in the path to our database file. So now I can actually browse the database from the command line. So I can do .tables to get a list of all of our tables. And we're looking for the auth user table. So I can do select all from auth user. These are the columns that we get back. So remember our password was 123, but here you can see there's no mention of 123. This thing here is my password. This is an encrypted password, and you can't go from this to get my password back. There's no way. The only thing that you can do is use this information to determine whether or not I know my password when I enter it in next time. So when I log in next, I type 123, it will run the same hashing algorithm on my 123, and it will get this back. So then it just needs to compare this with the database. So there's no knowledge of my password whatsoever. So now that we've determined that we are indeed not storing passwords in plain text, that ticks off our first goal for this lesson. So we're one step closer to being able to responsibly deploy our game to the internet. So the next thing that we need to do before we can deploy our game is something called encryption in transit. So we have our passwords stored securely, but we need to make sure that they're also encrypted while they're going from one machine to the server. So this is just because we are still sending our password in plain text. So if someone intercepted our network traffic, they would be able to see our password. We can use something called TLS to encrypt our traffic. So it stands for Transport Layer Security, and it's the same technology that you get when you connect to a secure site. So if you connect to your bank and you type in your password, the bank will have what's called a TLS certificate, which you can actually view on any website if you click the padlock button. And you can see it's got a lot of information, but one of the things that it does have is it has a public key. So this thing here is kind of like a key that you can use to encrypt a message. And this key is public, so anyone can encrypt a message with this key. But the only person that has a private key that can decrypt an encrypted message with this key, the only person that can decrypt is the server. And nobody except for the server has the private key. So the server can decrypt incoming traffic, but nobody else can. So if somebody intercepted your encrypted traffic, they wouldn't be able to do anything with it. So we're going to try to put that into our game. So luckily our WebSockets protocol supports TLS, but we need to make it so that the server is configured to do that. So we're going to, well, best practice really, if you're using version control, is to make a commit after every feature that you add. So I'm actually going to make a commit. So you'll notice there's a Visual Studio Code source control extension if you're in an initialized Git repository. And actually, if you're on Windows, you'll notice it says a lot of files have changed, but if you try to view the changes, there's nothing. You can choose to show whitespace differences, and it reckons that there's some sort of differences with the whitespace here. Yeah, so if you're on Windows and you get all of this, just if you know that you haven't changed this file, you can just click discard changes so that it stops telling you that it's changed. But in this case, we know that we changed manage.py and we changed models.py and protocol.py. And VS Code will show us the changes that we made so that we can review them. And then we can just click this stage changes plus button here. We can put all of these in this staged changes area. So once we're happy with these changes, we can give a message. So I'm going to type encryption at rest and then just click commit. And then you can come up here and you can click push. And if it gives you a message saying the branch main has no remote branch, just click OK. And if we go back to our GitHub repository now, we should see a new commit called encryption at rest. So we can actually click on this commit and we can see all of the changes that we made. So we know we've pushed this new commit to the repository. It's good practice to, every time you make a change or a new feature, to just make a quick commit and push that to the repository. But as I was saying, in order to implement TLS encryption in transit, we're going to come to main.py. We'll scroll to the top, and this line here from twisted.internet import reactor and task, I'm just going to add to that. We're also going to import SSL. So SSL is kind of like another name for TLS. It's kind of like an outdated name because we don't call it SSL anymore, really, but a lot of people still do. But you'll see it says this module implements TLS. Next thing we need to do is in the constructor for our game factory class, we're calling the constructor of the WebSocket server factory. And all we need to do really is just put an extra S here. So it should say WSS. So this stands for WebSocket Secure. So we're using a secure WebSocket connection now. And finally, I'm just going to replace our if name equals main block down here at the bottom of main.py. I'm just going to replace it with a couple more things so I can show you the difference. If I click this button here, let me show you what we've done. So we've added 2 new lines of code. So the first line, this is just a way of getting the current directory, and we're looking for a subfolder in the server folder called certs, and we're calling this the certs directory. And we're making something called a context factory. So this is an object that gives a little bit more context to our reactor. So we're calling SSL default SSL context factory, and it expects a private key and a public key. So these are the path names to a private and a public key. And these are required for TLS. Yeah, basically we're going to have something in a folder called /certs/server.key and then /certs/server.crt. So that means nothing yet. But when we change this line to, instead of reactor.listen TCP, we're choosing reactor.listen SSL, which indicates that we're going to be listening on a secure channel. And we're using the same port, the same factory, but we're also passing in this context factory object as well, so that it knows a little bit more information about what we're listening. So these are just the changes that we need to make to start listening over a secure channel. Well, so, I mean, yeah, if we start to try to run the server, we're going to get an error because, well, first of all, we need to install a couple of extra modules, but it also won't be able to find these certificate files because we don't have them yet. So yeah, let's set up our certificates. So we're going to create a folder inside server, and it's going to be called certs. And if you just maybe let's open up an integrated terminal in the certs directory. So we can see now we've got two terminals on the right hand side. We've got one in the server directory, and now we've got one in the certs directory. And this next step will require you to have a software installed called OpenSSL. So if you don't have OpenSSL, you can download it from this website. Well, this is for Windows. If you're on Linux and Mac, you probably already have OpenSSL installed. But if you don't, maybe just Google how to install OpenSSL on your particular operating system. But yeah, if you're on Windows, you can just go to this website here, which will be in the description, and it's also in the blog, and just download probably one of these installers. Probably this installer here, the Win64 OpenSSL version 3. Okay, so apparently I don't have OpenSSL installed, so that's slightly embarrassing. So I'll just install that now. So I'm going to download this MSI installer. And if it tells you that it's not secure, just click the three dots and click keep, and then just click show more and then keep anyway. And then you can just run this installation wizard, choose everything as default, and just wait for it to install. And then if you don't want to make a donation, you can just uncheck the boxes and click finish. And so if it still doesn't work, you can click start and type in environment variables, and you can click edit the system environment variables, and then come on over to the advanced tab and click environment variables at the bottom. For the system variables, you want to scroll down to where it says path. So make sure it's system variables and path, and then just click edit, and then click new, click browse, and then find where you installed OpenSSL. So it should be program files, OpenSSL, 64 Win, and then just click this bin icon and click OK. So now we've added OpenSSL bin. We've added that to our path. So if we click OK, get out of all this, then just close Visual Studio Code and open it up again. Okay, try again, right click in the certs directory, open an integrated terminal, and now we can run that command, no problem. Okay, so inside our certs folder, we now have a server.key file. So that's your private key. And just make sure that you don't show anybody this key because it is private, even if we're just using this for testing purposes. It's best practice to just keep this private key secret, because this is the thing that will let you decrypt any traffic. Okay, we're gonna create the public key certificate now. So this command will get you that, and this command's on our blog as well. We're using the private key to create a public certificate, and this is going to be valid for 10 years. This is a self-signed certificate, but when we actually create a proper certificate on the server, the certificates on the server will only be valid for 90 days at a time, so it doesn't give any attackers a chance to try to crack the certificate. Because every 90 days it will expire. But we'll talk more about that later. But for now, just for the testing purposes, we'll create a self-signed certificate. And it'll ask you a bunch of questions, but you can just leave all of these blank, so just press enter. But when it asks you for a common name, just type localhost. Localhost, all one word for the common name, and then just press enter. And then just press enter through all of them. So this is a public certificate, which is not private. You can show this to your friends, but yeah, this is the thing that you can actually use to encrypt traffic. I mean, we have our certificates. This context factory will be happy now, and then we should be able to listen in for traffic on the server. We do need to install a couple of extra libraries with pip to our virtual environment. So let's do that now. So we're going to make sure that we're in an activated virtual environment, and we're going to run pip install PyOpenSSL, and we're also going to install this service identity module as well. Great. So I'm just going to close the certs terminals. We're back to our server terminal. Let me just clear all of this. We should be able to try it. We should be able to run the server at this point. If we activate our virtual environment, of course. There you can see no complaints from the server. You can see Game Factory TLS is starting now. So yeah, if we try to connect to this, however, we'll see straight away disconnected unexpectedly. SSL error, HTTP request in, and closed connection unexpectedly, just SSL error. So remember, SSL is kind of another word for TLS. So we're getting some sort of TLS error. And the reason for that is we do need to make one change in, we need to make a couple changes in our WebSockets client.gd. So this was our scary networking script that we haven't touched since episode 1. But now we're going to make one change, which is a S here. So we're using secure WebSockets to connect. So if we try to run again, you'll see we still can't really get in, but this time we have another error in Godot. It says TLS handshake error, and on the server it says SSL error, SSL version 3 alert bad certificate. So yeah, this part's kind of tricky. I've never really been able to figure out why this happens, but I do know how to fix it. And I don't think it's a big deal. Some people might think that this looks like a bad idea. Well, I'll just show you what it is. So just in this ready function of WebSockets client.gd, at the end of the ready function, we're just going to add client.verify SSL equals false. And yeah, this might not look great because it's basically saying that we're not verifying the certificate on the server end before we start sending to it. But in practice, as long as you trust the server, as long as you own the server, and you know that that private key is secure and nobody else has access to that private key, and as long as you also know that nobody is modifying your game code to start sending to a different server, like nobody's hijacking your game, and this should be the case if you are the one that's in charge of deploying your game, and if you're the one that is in charge of hosting your server, and as long as you keep your passwords secure and nobody else is getting in, tampering with anything, this is fine. Your network traffic will still be encrypted, even if Godot is not verifying the authenticity of the server certificate. Everything will still be encrypted in transit, and obviously everything is still going to be encrypted at rest. So I don't see any problem with having this line here. If someone did get into your game files and tamper with your code, I think you would have a lot more to worry about. So we still have our server running, so we've added this line of code and we've told Godot we're using secure WebSockets. So let's save that and try to connect once more, and we can see client connected to server. So I can log in with the account that I created before, and I can get in just fine. And you can see on the server, everything is working correctly. These are all the messages that the server is decrypting. But if someone intercepted our traffic, they wouldn't see any of this. And I can show you now, there's a tool called Wireshark, which some people might use to intercept traffic. Yeah, I can listen in on my local traffic. I can start listening to packets coming in. So I've moved around a lot, I've sent a lot of packets. I can stop listening now and we can inspect them. So you can see, like, here's one of the packets that we're sending from localhost to localhost, because we're both running and serving the game. But you can see that this was sent. You can see that this was sent on port 8081. So this is most certainly traffic from our game. And you can see, first of all, the protocol here says TLS, so that's a good sign. And this is the this is what the data looks like. So this is just absolute nonsense. Nobody can look at this and say, oh yeah, I can see this guy's password. It's just not how it's working. So yeah, if you compared this with before, you would be able to certainly see the traffic. I can show you if I just revert all of the changes real quick. Okay, so you can see now, I've just changed it back to listen TCP. I've gotten rid of the context factory. We're not using secure WebSockets anymore. Actually, I should get rid of this extra S here as well. So we'll start the server, start the client, Okay, so it's connected. So I can start listening with Wireshark again. So we're now listening for packets. I'll just come to Godot and log in. So I'll stop listening now. Oh, so here we go. And we can see that this packet was sent in some manner from our server to our client, or vice versa. So we can intercept a packet like this, and we can see that this is a login packet. And we can see the first payload is my username, and the second payload is my password, just in plain text. So yeah, contrast that with what we were sending before we changed everything back. When we are using TLS, everything just looks like nonsense, so nobody can use any of that to do anything ill-intentioned. So change everything back to the way it was. Cool. Okay, so we've ticked off encryption and transit from our list of things to do before we go to deploy. So I'm going to make a commit, and this part's kind of important. I don't know, so we got apparently we got a bunch of changes to files that we never even touched. So if you're using Windows, I think there's a way that you can fix this, but I won't go through that right now. One thing you need to make sure you do is make sure you commit the change to WebSockets client.gd. So we did change this. We added an extra S here, and we added this verify SSL equals false, which, as we know, is fine. So make sure you add your main.py change, and do not add your certificate files. Don't upload those to GitHub. It's a bad idea. It might be okay to upload the public certificate, but don't even bother, because we're going to be generating certificates. Once we deploy the game to a server, we're going to be generating these again, so they don't need to be uploaded to GitHub. So yeah, just stage the changes to the WebSockets client in the main.py and type in a commit. So I'll put encryption in transit, click commit, and click the 3 dots and push. We've made all of the changes we need to make. We've uploaded it to GitHub, so now we're going to create a game server. So yeah, I've done a bit of research for you guys, and I'm looking for the cheapest, most reliable server to host. And I'm not sponsored or anything like that, but I did genuinely find that Amazon Web Services is the best bet. So yeah, Amazon Web Services has a free tier, especially if you're using it for personal use. So there's actually a 12-month free period if you choose a certain server type, which I'll be showing you how to do now. And then once the 12 months are up, it is still pretty cheap. It's still pretty cheap to run the smallest type of server they have. So just for reference, because I won't go over it at the end of this video, but if you are coming back to this after the 1 year is up, the server that you would want to change to is called a T4G.nano, and that runs on an ARM architecture. So you'd have to create the whole server from scratch, but you just make sure you choose a T4G.nano, and you can get a server for less than $5 per month. You can also, if you know you're going to be running your server for a long time, you can commit to pay upfront for a whole year, and I think it comes out to like $3 a month or something like that. So it's pretty cheap, but like I said, I'll just be showing you how to get set up for 12 months free. I'm sure you can figure it out from there. So we're going to create a free account. So just come to aws.amazon.com and then click create an AWS account up the top right here. And for the root user email address, just type in your email address. And I'd recommend just putting your email address for the AWS account name as well, just to keep everything nice and the same. It's easy to find things later. So just click this verify email address button. You'll get an email from noreply@signup.aws, and it'll be called AWS email verification. And if you scroll down, you'll just see a verification code that you can paste into this box here and click verify. So now you just need to choose a secure password. So like I was saying before, if you don't want anyone to be tampering with your things, you need to be choosing strong passwords. And I definitely recommend using a password manager like Bitwarden, which is free. So yeah, you can choose some really complex passwords. So just click continue. So at this point, make sure you choose personal for your own projects, and this will ensure that you'll get a free tier offer. And then just put in your details. Make sure you agree to the terms and just click continue. And here you'll be asked to put in your credit or debit or bank card number. So you do need to put your billing information up front, because if you do anything that's outside the realm of the free tier, so if you do anything outside of free tier limits, you will be charged for it. But if you follow this tutorial, and if you don't do anything outside what I tell you, you'll be fine and you won't be charged to the first year. You will get charged $1 so that they can verify your identity, but that's all. So let me just add this. And then because they need to verify your identity, I guess, they just need to send you a text message, so that then you can enter a code. So just type your area code and your phone number in international format, and just complete this security check and just click send SMS. That's probably the easiest way. So on your mobile phone, you get a message from Amazon Web Services, and my code is 1044. So we just click continue. And here it's asking for you to select the support plan. So we don't really need this, so we'll just choose the basic free support. So there's basically no support. Click complete sign up, but this is free. So if we click this button to go back to the management console, we'll just be asked to sign in again. So just enter your email address and your secure password. So cool, now we are inside the Amazon AWS console. So the very first step is to choose your region. So if you click the top right drop-down list, which will have the name of a region, we'll get presented with all of these different locations. These regions, whichever one we select, that will be where our server is located. So we ideally want to choose either a server that's close to us or a server that's close to the people that we anticipate will be playing our game. For me, I know that most of you guys, or like the highest proportion of you viewers, are from North California. So that's where I'll choose my server, because if the server is closer to the players, then there'll be a little bit less latency. So I've chosen my region. So the next step for me is to click services, come on down to compute, and then click on EC2. EC2. So we're in the EC2 management console, and we're just going to click this launch instance button right here. Launch instance. So this is us creating our server. So we can give a name to our server. So I'll just choose MMO. We can scroll down and choose an image now. So this will be the operating system. Make sure you just choose Ubuntu, because that's what all of the instructions in the blog are using. And specifically just choose the latest version that says free tier eligible. So if you click this drop down list, you might see a couple free tier eligible options, but just make sure you choose the latest version given by this number here. So at the time of this video, it's 22.04. So I've selected 22.04 Ubuntu, and it says free tier eligible. Make sure the architecture is 64-bit. But if you're coming back to this after a year and you have to start paying, it's actually cheapest to choose an ARM architecture. So if you're doing this before the year is up, choose 64-bit and choose this t2.micro instance type. But if you're coming back after the year, you can terminate this server to get rid of it. You don't want to pay for it. Choose ARM and then choose t4g.micro. t4g.nano, sorry. This is the cheapest. You can see it's $0.005 US per hour to run. So yeah, but for this tutorial, we're choosing 64-bit, very important, and t2.micro, very important. So this is the best free tier eligible server that you can get for the first year. So we need to choose a key pair. So this is required for us to actually connect to our server. So just click create new key pair. And we can call this MMO key pair. It's not too important what you call it, but it's important that you choose RSA and .pem. So RSA for the type, .pem for the format, click create key pair. So it will download a file to your computer. You can take this file and I recommend putting it inside a folder in your home directory called .ssh. Yeah, I recommend putting it inside a .ssh folder. This is not going to be needed for this tutorial. If you've ever connected to a server with SSH, you know why. But best practice is to keep it in a folder called .ssh. We will not actually be using this file. We'll be using the AWS console virtual terminal in your browser. But if you do know how to connect to a server with SSH, you'll know what to do with that key pair. And you should also know to keep that key pair file secret. Nobody should have that except for you. Okay, so network settings, we're going to keep most of this the same, but we're going to be changing this later. Storage, you can keep the default, which should be fine for our purposes. But also note here that you can choose up to 30 gigabytes of EBS storage. So if you really wanted to, I think you could choose 30 gigabytes of GP3 EBS storage. And that should be free, but I haven't tested it, so I can't actually recommend it. I'm just going to leave it as the default, and 8 gigabytes of GP2 is fast, and it's enough for our purposes. Just leave the advanced details alone, leave everything else alone, and then just click Launch Instance. And this should finish up fairly quickly. You'll see successfully initiated launch. You can click on this link. This is your instance ID. And this will take you straight back to that instance in the EC2 management console. So just see here where it says instance state is pending. We just want to wait until that says running. So we can keep clicking this refresh button until eventually it should go from pending to running. We're just going to change a couple of things while we're here. So first thing we want to change is select your instance and then click security. Down here in this bottom panel here, this is our security group. So this is kind of like a firewall. So we want to click on the name of our security group. It should say Launch Wizard 1. But if you click on this link, we can edit our inbound rules. So these are the ports that are allowed to connect to the server. So we can see currently we just have port 22 for SSH. We need to add a couple more things. So we'll click Edit Inbound Rules. So the first rule will be custom TCP and the port will be 8081. So if you customized your game port from 8081, you put your port number in here. But for me, I'm using port 8081 to run my game. So I'll put that in here. And for the source, just choose 0.0.0.0/0, and that means anywhere. You can also click on this drop-down list and click anywhere IPv4. So it's saying anyone is allowed to connect to our server over port 8081. We just need to add one more, and we'll choose port 80. And we'll also choose from anywhere. So this means anyone can come to our server over port 80. And that's actually the HTTP port. and that will be required later when we are automatically provisioning free free TLS certificates. In order to verify that we own the server, the service that we'll be using, the certificate authority that we're using, requires port 80 to be open. Yeah, just make sure you have port 80 and port 8081 in addition to port 2022. All of them are coming from this 0.0.0.0/0 source, and then just click Save Rules. So now we have our security group modified to allow extra bits of traffic in. Yeah, that's just running for the time being. That's fine. We're going to go and focus on something else at the moment now, which is required for having a free TLS certificate. We need something called a domain name. So currently our server has an IPv4 address, which is great. But we want to have a friendly name that we can refer to our server. So something like mmo.tbat.com or something like that. Something that we can refer to our server instead of just this IP address, because the service that we'll be using to provision free TLS certificates does not allow us to use an IP address. And I think in general as well, you cannot have a TLS certificate for an IP address. It has to have a domain name. So I'll be showing you how to get a free domain name now. So come on over to freedns.afraid.org. And you can see this is a free DNS hosting website here. So basically, people purchase domain names, but they let you sort of sublease a domain name for as long as you want. You do have to log into this website every 6 months to keep your subdomain active. But apart from that, it's completely free. So yeah, just click sign up free and just put your details here. And then just fill out this. So yeah, use the same email that you used for everything. I'd recommend just trying to keep everything, all of the services that you sign up for here, just keep everything the same if you can, because it just makes it easy to keep everything together. So just fill out the image challenge and click agree, and then send activation email. And with this one, it actually takes maybe 20 seconds to come through, so don't worry if it doesn't come through straight away, but you might also want to check your spam, just because it's like afraid.org sounds a little bit strange maybe to Gmail, but if we just keep clicking, we'll see an email from FreeDNS called welcome activation instructions enclosed. So if we just look at this email, there'll be an activation URL which we can just go to. And yeah, so now our email has been activated. We've created our account. So just make sure you remember your user ID and your password, because yeah, later on you will definitely want to be logging in every 6 months just to make sure that your account doesn't go dormant, because if you don't log in for 6 months, they will get rid of your subdomains and your game will go down. So just ignore this button. We're just going to click this registry button on the left-hand side here. It's showing me all the top-level domains that we can choose to have a subdomain for. So for me, I think it's best to choose one that's old, but it's also best to choose one that it's not being used a lot. So I like to sort by age by clicking the age column here. And now we're seeing the ones that were registered the longest ago. So these are the ones that are least likely to go down. But because the certificate authority that we'll be using to provision our TLS certificates, they will not give you a certificate if too many people are requesting certificates for the domain. So try to choose one that's not popular. So this one here has 288,000 hosts in use, so it's probably not going to be good to use that one. And in fact, probably don't even try to get anything from this first or second page. Let's go to page 3 after we've sorted by age. So these ones are still old. These are from 2004, so they're not likely to go down anytime soon. But we can start looking at the hosts in use. So we only want to be looking at the public ones. because these are the ones that are free to use. And we just want to choose one that doesn't have a lot of hosts in use. So for example, I'm looking, this one has 84. This one only has 70. So I'm going to choose this one here, this largent.org. I think that will be a good one because it's quite old and it doesn't have a lot and it's public. So I'm going to click on largent.org. And now this is where I'm choosing my subdomain. So you need to choose something unique here. So I'm going to just type in something I know probably won't be taken. So I'm going to try to register mmotbat.largent.org, and that will be my domain name for my server. So make sure A is selected. This is an A type. And then go back to your Amazon EC2 management console. Make sure your server is selected and just click this copy button next to the public IPv4 address. So we copy this IP address. We're going to paste it here. So in the destination field, we're pasting the IP address for our Amazon server. So that means that mmotbat.largent.org will point to this IP address. Leave the TTL and wildcard alone, and we'll just type in the challenge and click save. So now you can see here, I have mmotbat.largent.org registered to this IP address, which is the same as my server's public IP address. So we'll leave that a little while to propagate. Sometimes DNS can take a little while to actually come into effect, but it shouldn't take longer than like 10 minutes or so. Okay, so next we're going to connect to the server. I'll just leave this tab open so I can come back, but I'll probably also take note of this domain in case I forget it. But yeah, we're going to come back to the AWS management console. And you can just right click on the name of your server and click connect. So the username will be Ubuntu, and make sure you're on this EC2 instance connect tab and then just click connect. So we're loading into a virtual terminal here. So I can actually type commands, and this is a Ubuntu server environment. Okay, so we're going to do some configuration here. The first step is to get the server updated. So I'm going to be running some Ubuntu commands. So in case you're not familiar, sudo means you'll perform this action as the root user. So it's kind of like running as an administrator. And then I'm typing in apt update, which will update all of the packages on our server to make sure that everything's up to date. Next, I'll run sudo apt upgrade, which just sort of makes sure that everything's up to date as well. And at this point, it might ask you to restart some services that are outdated. So it's fine. We'll just select all of these just in case. So you can use the up and down arrow keys to move up, and then you can press the spacebar to select. And once you've selected all of these, just press enter, and it will go ahead and restart those services. The next command is to update the snap. So this is kind of like another package manager for Ubuntu, which we will need later to install our certificate provisioning service. And we're just going to refresh that snap. So it says no updates available, that's fine. We're just going to configure our firewall. So yeah, you might not have the firewall enabled. So we've got this program called UFW for Universal Firewall, I think. If we check the status, it probably says it's inactive. But just in case you choose to enable it later, we're going to allow port 22 with sudo UFW allow 22. So that's for SSH. We'll also be allowing port 8081, so that's for our game to run on. And if you customized your port, you would type a different number here. And we're also going to allow port 80 for our certificate provisioning authority to verify our domain. So yeah, we'll allow all of those ports through. You don't really need to enable the firewall though, because we have the Amazon security group, which only allows certain traffic through. But if you do want to enable your firewall, you can choose to run this command sudo ufw enable. So yeah, just make sure that if you're enabling the firewall, you're at least letting these 3 ports through, because it's very important. Great. So we can actually start to get our game up and running on the remote server. So the reason that we uploaded our code to GitHub is so that we can use this git clone command on the server, and this will download our game files. All we need to do is get our GitHub repository URL and type git clone on that URL. So I've downloaded my code. So if I do a ls to list the files in the current working directory, I have this MMO folder, and I can actually cd to change directory into the MMO folder. And I can do an ls from here, and we can see all of our stuff. So I'm just going to cd into the server folder. And yeah, we need to set up our virtual environment. So if you're using the latest version of Ubuntu, you can't just use the python-m venv command. You need to first install the python 3-venv package from apt. So just type sudo apt install python 3-venv and just press yes to install that. So now we can type python 3-m-venv. This is the same command that we always use. So this works now that we've installed that package from before. And we can just activate that. So we should see the venv prompt here. So that's always a good sign. And we can just go ahead and install our prerequisites. Same as before. So install Twisted, we're installing Django. And don't forget, now that we're doing TLS, we're going to install PyOpenSSL. And we're also going to install service identity. Okay, so next let's make our migrations so we can make the database. So python manage.py make migrations. Actually, no, scratch that. So I made a mistake. I tried to run migrations before I had the migrations init.py folder and file. So to remove a file in the terminal, you can type rm for remove, and then I'm going to remove my db.sqlite3 file. So we can see it was here before, but now it's not. Let me actually create my migrations folder. So yeah, again, make sure you should have already made sure, but make sure you are indeed in the server subfolder, and we'll do mkdir for make directory. We're going to make a directory called migrations. So we should see a migrations folder now. And we're going to do touch migrations init.py. So this will just create a blank init.py file inside the migrations folder. So now we can run our database migration. And you'll see the correct output this time. And then we can perform the migration. So there we go. That looks good to me. So before we can run our server, remember we need to make our certificates. So we're going to make another directory called certs. We're going to cd into that directory. So now we're in an empty directory called certs. So we're going to install a new software from our snap called certbot. So this is the software that we'll be using to provision automatic TLS certificates every 90 days. So sudo snap install -- classic certbot, and we'll run that. Okay, so it says installed. We need to make a link just to make sure that it's all installed correctly. So just type sudo ln -s /snap/bin/certbot to /user/bin/certbot. Just note that user here does not have a E. So it's best to just copy and paste all these commands anyway, but yeah, you can press enter. You should get no errors. And now we are going to get our certificates. So we'll run this command, sudo certbot certonly -- standalone. And now it's going to ask us a few questions. So we need to answer the questions the best we can. So for email address, just put the same email address you've been using this whole lesson. Terms of service, just press Y to agree. Yeah, it's asking if they can share your email address, so you can just press no if you don't want to do that. That's totally fine. And now it says, please enter the domain name you want on your certificate. So I am going to enter mmo.largent.org, which is the one that I registered on the freednsafraid.org website. But you would put your domain here that you registered. And if enough time has gone through and the DNS is propagated, then we should see requesting a certificate and successfully received certificate. If you get an error at this point, it might be because you haven't waited long enough for the DNS to propagate, or it could also be that you haven't allowed port 80 through your security group, and you might have also enabled your firewall without allowing port 80 through. So maybe just try disabling the firewall and checking your security group for port 80. And if that doesn't work, maybe just wait another 10 minutes and try again. And if it still doesn't work, then I would definitely recommend just coming into the Discord and asking if anyone can help you troubleshoot. So regardless, we can see that our public certificate is saved to this directory here. So I'll copy that for later. And our private key is saved to this same directory. It's called privatekey.pem. But as we know, we are expecting our server to load in 2 files in this directory that we're currently in. So we need to copy these files to the directory that we're in now. Okay, so let's do that now. So I'm going to type sudo cp for copy. I'm going to paste the directory that it said here. So I'm pasting the path to our public key file, and I'll put a space, and then I'll paste that I want to save it here, and I want to call it server.crt, because that's what Python will be expecting. So if I press enter, I don't get any errors. If I type ls, I now have a public key file called server.crt in the current directory. So I'll just repeat that step for the private key. So we want to call it server.key, and the file is called privkey.pem. So if I ls again, we should see server.crt and server.key inside of this certs folder. So I can go back to the server directory by typing cd space and then ... So ... means back a level. And you can see I'm inside my server folder. So I've got my virtual environment, I've got my migrations, I've got my database, and I've got my certs. So we should be good to start running the game now. So I'll type python space ... And you can see here we're getting an error. And I know there's a problem. Let's go back to our certs directory. We can see that we got server.crt and server.key, but Python is saying that there's a problem, something to do with the certificates, and it can't find, or it can't open the file. So what's going on is if I run stat star, this will let me look at the permissions for the 2 files in this directory. And we can see that both of these files are owned by a root. So they're actually not readable by the average user. So what we need to do is we need to change the ownership of these files by running sudo chown for change ownership, $user space star. So this changes the ownership of all of the files in the current directory to our own user being the owner. So if we type a stat star again, we should see now Ubuntu is the one that owns these files. And Ubuntu is the user that our server will be running as. So if we do a cd ... again and try running the server one more time, we should see Game Factory TLR starting on port 8081 and no errors from that. So we should be good. Let us open up Godot. So I've just got Godot open alongside the remote server's output. We need to change a line in main.gd. So open main.gd. So find where we're connecting to the server. So in the ready function, we're doing network client.connect to server. And instead of 127.0.0.1, that would previously be referencing our local network. We actually want to put the domain name of our remote server in here now. So this is where I'm going to put mmotbat.largent.org. But you will obviously use your domain name that you registered. So we'll save Godot. Let me click run. And you can see here the remote server is saying WebSocket connection open, client connecting, and this is my IP address. So that seems to be working well. And on the Godot side, you can see client connected to server. So let's try to register. We can choose our avatar. And it says registration successful. So we are successfully connecting to a remote server somewhere else on the internet. So we are no longer hosting our server ourselves. We could be anybody in the world right now connecting. So that's pretty cool. You can play with your friends, play with your family. We just need to get this game client out there now. We just need to we didn't make this more accessible for other players. So ideally we're going to host this on itch.io on the web so that anyone can just visit your link and start playing. So I'm just going to close this. So I'm just going to press Control-C to stop the server for now. There's one thing that we need to make sure we're doing. So like I said, every 90 days, these certificates in our certs folder, every 90 days, these will expire and they will not be accepted by any clients anymore. So these are no good after 90 days, which means every day we're going to try to renew these. I'm going to see if these are up for renewal. But don't worry, we'll do this automatically. We're going to write a script and I'll show you how to make the server run the script every day to check if these need to be renewed. And if so, then it will renew them. I think by default, because this free service we're using is called Let's Encrypt. By default, the Let's Encrypt agent, if it's less than 30 days until it expires, it will choose to renew it. So it's not trying to cut it close or anything like that. It'll renew pretty much every 60 days if we're checking every day. But they do expire every 90 days. So there's a 30-day buffer. But if we set it up like this, our certificates should not be expiring. So I'm going to make a script. Well, I've made a script and it's available on my blog. Yeah, I'll put a link to the blog on the screen right now that you can go to. But I'm not going to help you type out this script because, yeah, I don't know, like Linux shell scripting is an entirely different topic. So I've written this so that you don't have to. So we're going to put a script in our server's bin directory, which is a very accessible directory for scripts. So type sudo nano. So nano is the name of a text editor on Ubuntu. And we'll do /bin/copy-certs.sh. So sudo nano bin/copy-certs.sh and press enter. Now just come to my blog and copy this code that will be around 3/4 of the way down under the keeping the server secured. Let me show you. So yeah, around 3/4 of the way down under this heading, keeping the server certificates renewed, just copy all of this and paste it into Nano. So you can use the arrow keys to go up and down. So you can see we've copied all of this. Make sure you've copied all of it. And then press Control X. And then press Y. And then press Enter. So if we press up and run this command again, we should see that we've saved this folder. So you can press Control X to exit again. So yeah, you don't need to worry about what the script does, but all you need to know is that it will try to renew the certificates every day. And if the certificates need to be renewed, then it will do so. And it will copy the certificates to this location, overriding these old files, and it will change the ownership again. Okay, so we need to change, we need to modify that script that we've just made. So we're gonna run sudo chmod for change modify plus X to make the script executable. And then we're referencing the location of our script. So press enter. So now our script in our bin directory is executable, which means we can run it. Okay, so now we're actually going to just go back a couple steps. So we're now in our server folder. We're even gonna go back one more step. And we're in just our project folder. So it should say tilde/MMO or whatever you decided to call your repository. So we're here and we're gonna run this command. This is also from my blog here. So we're gonna run this command here and press enter. And you'll see some output. So this output, we wanna copy. This is just getting like the directory to our project folder. This is the name of our current user, and this is the location of our script. And this you'll see about this. But we're gonna set up something called a cron job. So a cron job is something that runs periodically on a Ubuntu server, and it gets run automatically like every day, for example, or every minute on weekdays, or something like that. You can set up a lot of different rules. So that's what this is kind of representing here, but I'll show you. Type sudo crontab -e. So we make sure you use the sudo here, otherwise it won't work. We want to run the script as a root user every day. So if you do sudo crontab -e for edit, we're going to be editing the cron job rules for the root user. So it's asking us to select an editor. So since I showed you the nano editor before, we'll just go with that again. And you can see it's also saying the nano editor is the easiest. So we're just going to type 1, press enter. And this is our cron tab file. So this is for editing cron jobs. So we're going to arrow key down to the bottom of this file. And we're going to paste the output that we copied earlier. So this is the output from that command we ran. So you should have copied that, and now you're going to paste it at the bottom of this cron tab file. And you can see now what everything represents. So the first number here is the minute. So we want to run this on the 0th minute. We want to run it on the 0th hour. So this is saying we want to run this at midnight on every day. So we want to run this every day of the month, every month of the year, and every day of the week. We want to run this command midnight every day, basically. This is the command that we're running. So that's the script that we made before. And these are some parameters to our script that we don't need to worry about. But this will ensure that the script knows where to put the certificate files, and it knows who to set the ownership to. So press Control X and press Y, and then press enter. So if we type sudo crontab -l, we can list the root user's cron tab. And we're seeing here we've successfully put that line of code at the end of the cron tab for the root user. Okay, so that's going to run at midnight. It's going to run every day at midnight. So that's good. That's what we want. But if you want to test this for yourself, just copy this, everything past the asterisks, copy from here to here. And you can try to run this right now if you want to see if it works, and hopefully there shouldn't be any errors. So paste that and press enter. And I need to run it as root. So I'll type sudo before all of this code. Keep everything else the same and press enter. We'll see here that we, let's see. So it says attempting to renew Let's Encrypt certificates. And so it's processing like the domain config file. And it says certificate not yet due for renewal. So no renewals were attempted. And it'll go through and copy the file anyway, because why not? So it's copying the files from the location to our certs directory, and it's changing the ownership as well. So yeah, if you got this kind of output, then you know that the script's working. So it's going to run every day, and one day the certificates will be due for renewal, and it will renew them, and it will copy them and change the ownership for us. So we do not need to worry about certificates expiring anymore. So now we just need to we need to make sure that our server is running. We need to make sure that it's running at all times, and because if we just went to the server, and if we just did python dot, and then if we closed this window, if we went back out of here, you know, so if we close this window, if we close this tab and went about our day, the server would stop running. It'll just stop running as soon as we close this terminal. So we don't want that. We want to use something called tmux. It's a terminal multiplexer, which is just a fancy way of saying it can run things in the background. Make sure that you are in your server directory and run this command, which is also on my blog. So tmux, new session, we're calling our session game server, and we're going to run python dot. So if we run that, we should be able to connect to our game still. Cool. So yeah, we're still connecting to the remote host. So we're still connecting to the remote host, but if we close this tab now, we'll still be able to play the game. If you want to look at the output of your tmux session, you can type tmux attach -t game server. We can see here all of the output. If you don't want to be looking at the output anymore, you can press Control B and then press D. So you're not holding Control anymore. You've just pressed Control B. You let go of the keyboard, and now you just press the letter D. Okay, it's kind of weird, but it's just the way it is. That's also written in the blog. That's good to remember. If you want to kill the tmux session, you can type tmux kill session -t game server. So we've just killed the session. So if we try to connect now, see, we're not getting anything here that says connected. So nothing happens when we try to log in. So the game server is not running right now. But yeah, again, you know, if you want, and also make sure you've got your virtual environment loaded. But yeah, if you want to start the game, you should use this command so that then you can close the server. So I've just run the command. I'm going to close this. So I'm no longer connected to the terminal. But if I run the game, you can see client connected. I've written a little guide for you here. So if you ever need to make any changes to your server, the process to update the game is you need to make changes to your server code. So pretend I made some changes here. The next step would be for me to push the changes. So I can stage the changes, click commit, and then push. Then we would connect to our EC2 instance. So we can do that from the AWS console by coming into instances, right click our MMO instance and click connect again. And the next step is to stop the currently running game server with this command. So pretend I'd run that, I guess. You know. And then we'd move into our repository, run git pull. So that will pull in any changes that we might have pushed previously. Want to make sure that our virtual environment's activated, and then run our make migrations and migrate scripts to pull in any database changes we might have pushed. And then we'd start a new session again with this command here. And then you can close everything. So this is a 10-step process for updating your game. You can automate this process. You can do that with something called GitHub Actions. And I've done this actually on the official Godot Python MMO repository. I have done this. You'll see this little .github/workflows folder, and inside you'll see a main.yml. And Basically, it's saying that every time the code is pushed, it will automatically do this. It'll connect to the server and it'll run this command and then this command, and then it'll check out the latest tag. So it's a little bit more complicated, but then it'll activate the virtual environment, make migrations, and then run the server with tmux, and then that's it. So yeah, you can use this if you know what you're doing. I don't think I should go into it in this video because this video is already long enough. But yeah, just know that it is possible to automate the update process. It is possible to automate these 10 steps. Great, so we've got our server running. I think we still have the server running. Yep, okay. I can also verify that by doing tmux attach -t game server. And I can see that the server is running, so I'll press Control B and then D. Now I can close this. We are done with Amazon. Great, okay, we're done with this as well. Okay, so the final step is client hosting. So we've got our game files on GitHub, we've got a server running, and we've set up the server to responsibly start serving the game. We've configured our client to connect to our new game. So what's next is we need to host the client on an accessible location for all of your family and friends to play the game with you. So for this, yeah, I think HTML5 is the best export option, just because nobody has to download anything, nobody has to install anything. So make sure your main.gd still says the name of your domain here, and make sure it's saved. And then we're going to go to Project, Export. We're going to choose our export preset of HTML5 that we already had from lesson 1, I believe, or lesson 2. So we're going to select that. We're going to make sure you scroll down and select the experimental virtual keyboard option. So we discussed this in lesson 4, so it's for mobile users. And then just click Export Project. And click, let's make a new folder called HTML5. And we're going to make sure we call it index.html. Just leave everything as usual because I haven't tested, but you might want to experiment with unchecking this box. You might get some more performance if you don't have this ticked, but I haven't tested that, so I'll leave that up to you. But just click Save, and then Export Project. And it's going to ask us again, but yeah, just make sure it's HTML, index.html. Save, okay, fine, everything's good. Let's do a really quick test to make sure we can actually run on HTML5, because we haven't actually tested that yet. Okay, cool. Yeah, we are indeed connecting to our remote host. You can click the 3 dots if you're using Chrome, and then click on More Tools and Developer Tools if you want to check. If you click on the Network tab, and if you refresh, you should see the name of your domain, the name of your virtual server with WSS Secure WebSockets here. So yeah, this is how you can also verify that you are indeed connecting to your remote host. Great, okay. So we'll close this. We're going to make an account on itch.io. So come to https itch.io, and itch.io is a very common game distribution platform. It's kind of like Steam, but they don't have as many loops and hurdles for you to jump through when you're trying to get your game out there. So we're going to be using itch.io because they also have a way of playing games directly on their website. And it's free. So yeah, we're just going to make an account by clicking this register button up the top right. And we're just going to choose our username, choose our password. And you should be keeping all of these passwords distinct and secure. And I definitely recommend using a password manager like Bitwarden. Because yeah, we really responsibly trying to deploy online games. There's a lot of responsibility that no one is like reading people's passwords, intercepting the network traffic, or replacing your certificate, or replacing your domain, or anything like that. You really want to make sure that you're keeping this all secure. Big responsibility, but I think as long as you're choosing distinct, secure passwords and not sharing them with anyone, you should be good to go. Just, yeah, about you section, you can uncheck these. Maybe you can put, I'm interested in distributing content to itch.io. I'm not sure, but we'll just tick this one. Same email address as before, and then just click I accept. So we're going to click this button to create a new project. And you can give it a name. So I'm just going to call mine Godot Python MMO. And the default project URL might be fine, or you might want to change this. It's up to you. You can upload cover images, you can add screenshots, gameplay trailers, fill out all of this if you want. The most important parts I'll just be going through, and you can change the rest yourself. For the kind of project, you definitely want to choose HTML. And it says you need to have a zip or a HTML file. So we need to zip up our project. So come to your project folder, go to the client subfolder, and then zip up this HTML5 export folder. So I'm going to zip this to html5.zip. And if you scroll down to this upload files button, click it, and then find your html5.zip. If you haven't verified your email address, you should do that now. So let me just check my emails. I have an email from itch.io, and I just have a link to verify my email address. So let me click that. Okay, your email address has been verified. So let me try to upload that again. And this time it should let me. And just leave all of these alone, or you can change the display name if you don't want it to be html5.zip. Yeah, you can mess around with this, but this part's important. 640 by 360 is really small. I would probably go with at least 960 by 720. And if you go too much bigger, then you risk people with smaller displays, like people on their phones, not being able to see it very well. But you can also click to add a full screen button, and you can also make it so that it says it's mobile friendly. Just leave the orientation as default. Everything else is optional. You can scroll all the way down to this part, and it says here, to make it public, we need to save the game first. So we'll click this save and view page button. Okay, and we can test our game from here. So we should be able to log in. This should be connecting to our remote host. Cool. Okay. So we finally have our game online somewhere that's not being run locally by our machine. This is all online. So we're using TLS to encrypt our network traffic. We're using Django to securely store our passwords in a database. And we've locked everything down, and we are doing everything correctly. And now we can play with our friends. The only thing you need to do is click this edit game button to go back to the edit page. Scroll all the way down and then tick public. And now anyone can view the page. Anyone can play our game. So you can click save. So now if we view the page again, I can copy this URL and share it with my friend. Let's say my friend is in a completely different browser. He comes to visit my game, and he can click this run game button. And by the way, if you don't want the run game button, I think there's an option to automatically run the game, automatically start on page load. You can tick this if you don't want your friend to have to click a button. So yeah, he can register for an account. Registration successful. Okay. And he can log in. And then you can log in as well. And you can now play together. Completely online. There's no self-hosting required. There's no nothing like that is required. This is all online, available for anyone to come in and play. Yeah, you can go full screen mode. You can also click this embed button if you want to embed the game on your own website. You can do that. So this is all very exciting. You've got your game up online. If if you made it to the end of this very long tutorial, thank you for reading along or watching. I really appreciate it. Hopefully this is worth it, because now you don't just have to play by yourself. You're a real game developer now. You've deployed your own production game. You're doing everything sensibly, and you should feel very proud of yourself if you made it this far. So yeah, just remember, it's free for the first year. After that, you have to start paying, but you can change to a T4G Nano ARM server, and that should be about $5 a month, $5 US a month. Make sure to every now and then come on into freedns.afraid.org and make sure you log in. It should let you sign in. Make sure you do that every 6 months, otherwise your domain will disappear. Even if that happens, you can just log in with your existing account, and everything should come back up. But if you have players that are playing your game and you don't notice that your domain has expired, then that can be not good. You can also buy your own domain from somewhere like Namecheap. That's, maybe a little bit more of a stable option, but if you want it to have it for free, then this is the website to do it. Just make sure as well that in addition to the 10 steps that I mentioned every time you update your game, the last step is to re-export and re-upload your client files to itch.io. So if you make changes on the client side and you want to update the client side of your game, then just make sure you re-export, re-zip, re-upload, and your players will be able to see your new latest updates. Alright, yeah, and if you made a cool game, then be sure to share it in the Discord. We have about 21 members now, so yeah, we can share our games together and give each other feedback as well. So yeah, make sure you do that. If you had any questions or feedback, please let me know as a YouTube comment, or you can join the Discord and let me know. Especially if you can't quite figure something out. This tutorial has a lot of steps, so it's possible that something's gone wrong, and don't feel bad if it does. It's a very complicated topic. Just know that if you are having problems, then you can always come to the Discord and anyone will be happy to help. Cool. So hope you have fun, and hope you have a safe Christmas and Happy New Year, and I hope you take care. Thanks. Bye.